So, 5.2. So the first thing is we're going to be naming polynomials in this section. So we're going to be using technical terms. Okay? So when it comes to naming polynomials, there's actually two names for each polynomial. Okay? We name things by the number of terms they have, and we name things by the degree. So the first thing is going to be the name by terms. So what does the name mono mean? One. So how many terms? One term. So anybody remember, when it comes to identifying terms, what symbol separates terms or symbols? What separates two terms? No, well, that is a term, right? A variable and a number make up a term. What operator separates the terms? Addition or subtraction. So plus and minus signs, not negative signs. Okay? You notice on your calculator there's a negative button and then there's a subtraction button? Those actually mean different things. The negative just means times the negative one. Subtraction means take the thing that I put in first and then remove this from it. Okay? So plus and minus signs are what creates terms. So if I want one term, how many plus or minus signs am I allowed? None. So no plus or minus signs. Does that mean that I'm not allowed to have a negative? No, I can have a negative all day. I just cannot have a subtraction sign. Okay, because subtraction in itself involves two pieces. So real quick, can you give me an example of a monomial? Negative x squared, that works. 8, that works. What about okay, that's still a monomial because do I have any plus or subtraction signs? No, I still have one term. Even if I turn this into a negative, I don't have anything in front of it, so this is still a single term even though it has a negative sign because that is not a subtraction sign. Is everybody okay with that subtle separation? We know what mono means. What does bi mean? Two. So how many terms? Two terms. So if the item has two terms, we call it a binomial. So how many plus or minus signs should we have? One. Can anybody give me an example of a binomial? So 2 plus 2 won't work, but 2 plus 2x would. Because can I combine a 2 with a 2x? No, because they're different terms. So they're not alike. So when you're naming these, right, because we always condense things as far as we can and simplify, we need to make sure that they can't be simplified into a monomial. Any questions on binomial? Okay, so any arrangement of powers works there as long as you have two pieces. Everybody good? All right, so what do we call something with three, or what do we call try? 3, yep. So that's when we have three terms. And give me 1 minute here and all right, 3 terms. So how many plus or minus signs? 2. Can anybody give me an example of a trinomial? Three x plus 2y what? Plus 8. That works. All right, in chapter 4, we spent a lot of time solving and factoring quadratics, right? So you saw a whole bunch of trinomials because you saw stuff like that, right? Correct? So we spent a whole bunch of time with trinomials. So from here on out, we're going to be naming things appropriately. So you're going to hear me talking about quadratic trinomials and linear binomials and things along those lines. Okay? Any major questions on try? So what does the word poly mean?
4.
Many. So for us, in this situation, it's 4 or more. So more than 3 terms. We just use a generic polynomial term. And there's a whole bunch of options here, so I'm not going to write one in. But it just means that there's more than 3 terms. Every function is going to have 2 names, one by the number of terms and one by the degree. So these are the term names. We have monomials, binomials, trinomials, and then polynomials. But we also have to name an object based off of its degree. So we have constant, linear, quadratic, cubic, quartic, quintic, and then we have a different word past quartic, or past quintic. And this is what I mean when I say the hierarchy of polynomials. Okay? Our most basic polynomial is going to be a constant, and then it goes up from there to linear, quadratic, which we've spent a lot of time dealing with, right? Linear was 1 and 2. Quadratic was chapter 4. And then in this chapter, we're going to get into cubic, quintic, and quartic. And basically any polynomial out there. Okay? So again, you should have seen this, but if not, make sure that you get what you need. So it's no big deal. Who knows? What's a constant? What does it mean to be constant? To change, or to be the same and to not change, right? So what object do we use in math to represent change? Delta. Okay, yeah. Delta does mean change. This object, that's actually not what I'm thinking. Sorry, I completely spaced on that. My apologies. What object do we use to represent something we don't know? Which is called a variable. What does the word variable come from? What word? It varies. What does it mean to vary? To change, to be different. So, if I want a constant, can I have a variable with my constant? Can I have something that represents change with something that can't change? No. So, in general, a constant is considered degree zero, but it really means no variable. Okay? Because the second I put a variable up there, I'm changing my possible outcomes. Everybody okay with that? Yes, no? So I can't guarantee that the object won't change anymore. So can you give me an example of a constant? 0 works? Is 0 ever anything other than 0? No, it's always 0. Can I get another constant? 1. Okay. Pretty much. No, for constant. So for a constant, yeah, there's no variable, so we're really just left with our numbers. Everybody okay with that? So, linear function, right? So what's the degree on a linear? So if it's a line, the biggest power is 1. So the highest power on x is going to be a 1. Okay? So can you give me an example of a linear function? Yep, so the power on x has to be 1.
It could be like 25,000.
X, 25,762x. So kind of like something that we're used to seeing, right? So what's your most common form for a linear equation? So this linear function is basically anything that looks like this, where the highest power on x is 1. Everybody all right with that? Yes, no, maybe. So again, you're used to seeing all this stuff, right? All right, quadratic function. What's the highest power on x going to be? 2, because that's the primary variable we use. And when you throw in y and z, we go away from two-dimensional and start playing with 3D, which we don't have a lot of experience with. So like everything you're going to see, it's going to be power on x, because it's going to be the only variable that is an independent variable that's going to be in play. All right, so anybody remember standard form of a quadratic equation? Ax squared plus b what? Plus b. There's a plus c, but what's missing? X. So when you write out a standard form, you have to have every power represented, okay? And that's going to become really important when we get into synthetic division and synthetic substitution later on in the section. Whenever you substitute or divide something, you have to make sure that every power is there. So if it's a quadratic, you need the power of 2, power of 1, and a constant. Okay, just like when we get into a quintic, we'll need a power of 5, a power of 4, a power of 3, a power of 2, a power of 1, and a 0. Everybody okay with that? Yes, no, maybe so?
Yes.
All right. Cubic function, what's the highest power got to be? Tres. Wunderbar. And I totally just mixed languages again. Es muy bien, señor. So what's your standard form of a cubic function, do you think? Ax cubed plus bx squared plus, well, I've got a power of 2 here. I need an x. So it'll be plus cx plus d. We don't have this type of c, guys. We have 26 letters to pick from. Everybody okay with cubic, right? That's where we spent most of our time. Now, yep, ax cubed plus bx squared plus cx plus d. Is that better? Okay. Sorry. All right, sloppy. The degree of the polynomial, it's going to force the graph to do and look like what it says. So if the biggest power is a 3, your shape is a cubic function, and we know a whole bunch of characteristics about it. Because this 3 is so powerful, it's going to override the squared and the x. So the squared and the x are going to impact what the shape looks like, but the overall shape will do whatever the cubic says. Does that make sense? Okay. So what about for a quartic? What does quart stand for? 4. Anybody know standard form of a quart? Perfect. So there you go. Boom. All right. Ax to the 4th plus bx cubed plus cx squared plus dx plus e. Any questions on quartic so far? So up next, that is quintic, which is kind of weird because we tend to use penta. It really comes from English, right? Would it make sense for me to say a pentaic function? Does that sound proper? No. I might be able to say like pentic, but the actual ending is P-E-N-T-A, not P-E-N-T. So that's why it's like a pentagon. It's not a pentagon, right? Because the actual prefix is penta. Everybody all right with that? So like pentaic doesn't make sense. So we use quintic because quint means 5. Okay, it's just not used very often, but it does actually mean 5 of something. All right, highest power of 5. Anybody know what's standard form of a quintic? Perfect. Kind of. Like, instead of writing out full-on examples, this is what a quintic will look like. Okay, as far as in standard form, this is what we need to see. So if I give you a quintic and I want you to substitute, or more importantly, when we get into synthetic division or long division, you have to write that all the way up. If I gave you like this, is this in standard form? It's a quartic, right? Which means that I need to have a 4th power. Do I have a 4th power? Okay, I need a 3rd power, do I? Do I have a 2nd power? Right, so I have to add it. So when it comes to long division and synthetic division, what you'll have to be able to do is do this. Take this and add in the missing pieces by using zeros as placeholders. So this is what you'll need to be able to do in order to perform synthetic or long division properly. Okay? So when we get into the division stuff later on in the chapter, it'll make more sense. For right now, I just want you to understand that whenever I say standard form, I mean you have to have every variable represented. So that means that if I have x to the 5th, I need every power under it. So I'll need 5, 4, 3, 2, 1, and a constant. Okay? Does that make sense? All right. So, and this is the examples for naming the polynomials, right? So when we name a polynomial, we have to use both names. So the question is, according to English, which one should come first? The majority of the time, it's actually going to be the degree that comes first. So if you use one of the names off the chart, constant, linear, quadratic, or cubic, quartic, quintic, that name will come first, and then the number of terms. That changes because of the rules of English when we're naming a degree bigger than 5. So real quick, what's the biggest power on x here? 4. So what do we call a polynomial of degree 4? Quartic. How many terms do I have? Right. So if you notice, I have 2 plus or minus signs, right? Which creates 3 pieces. So now I'll put the 2 names together, and what is it? There it is. It's around here somewhere. So this is a quartic trinomial. So for the second one, what's the highest power? So what do we call something of degree 2? Quadratic. And how many terms do you see? Uno. So what do we call something that has uno terms? Quadratic monomial. Everybody all right with that? Yes or no? All right. For the last one here, what's the power? What's the biggest power? 6. What do we call something of degree 6? Do we have a name for it? No, so it's just of degree 6, right? So how many terms do you see? 2, so what do we call that? A binomial. Now, if I named it by degree, right, would it make sense to say a polynomial of degree 6 binomial? No. So because the English has to still make sense, when it's degree of, we actually flip the order. So we go by the number of terms first, and then the degree. So how many terms does this thing have? 2, so it's a binomial, right? and it's a binomial of degree what? 6. So if you notice, we just call it a binomial of degree 6. Okay, so the language is a little bit weird there, but if you say it and it doesn't make sense, then you probably have the order backwards. Because, like, we don't end things with ick. Like, if you flipped the number 2 there and you said a monomial quadratic, that doesn't really flow too well versus a quadratic monomial, right? So you shouldn't be ending in icks. Any major questions on naming, though? So that's our naming system, right? We're going to name by degree and then terms, unless it's bigger than 5. Okay? Everybody all right with the names, you think, maybe? All right, do you guys remember seeing this last year? Okay, good. Good. Up first is we're going to be looking at odd functions. So we have odd and even functions here that we're going to be playing around with. So please get this bit copied down. So we've got odd, and that's by degree, right? So, like, if we just look at the ones that are named, we try not to be sneaky with our names in mathematics, okay? So when I say an odd degree, what functions do we have names for that are odd degree? Okay, a cubic, that would be an odd degree. What else? A quintic. And then what other one do we have a name for? Linear, right? Linear is a degree of 1. So when we say odd function, it's actually based off the degree. Okay, so first degree, third degree, fifth degree, seventh degree, ninth degree, right? We know what their graphs are going to look like because they're an odd degree.